This particular one, we want to write the formulae of the following compound: potassium hydroxide, calcium triazonitrate and lead 2 triazocarbonate 4. The formulae should be written like how? How should we write it? Now, potassium hydroxide, you should know that potassium was first mentioned, and hydroxide is in your notes as we've done that OH minus. That's hydroxide. Potassium is K plus. So now we have 1, 1. Anytime it is the same number, the valency is the same, you don't need to write any number to exchange. Just write, combine it, KOH. Anytime, see 1, 1, 2, 2, don't write the number, just combine the symbols together. Do you understand? Anytime it is the same. Now, you will do number 3, I will do number 2. This is number 1. Then number 2, we have calcium, Ca. Please make your C to be a capital letter while your A to be small letter. That's how to write calcium. Now, trioxonitrate 5 is there in your node. It's a radical. Trioxonitrate 5, see, this is it. NO3. Trioxonitrate 5 is always having a minus. That's the essence of me writing those radicals before we start this. So this one is 2 and this one is 1. So when you exchange their valency, you get calcium is 1, while this one is picking 2. So you are going to open bracket. Since it is picking 2, you write the NO3 and you close bracket before you write the 2. So this is calcium triazonitrate 5. So that is how to do calcium triazonitrate 5. So this is NO3 triazonitrate 5. This is calcium. Then the 2 become Ca open bracket NO3 close bracket 2. So that's how to, from name you can write formula. From formula you can write the name. So it's as easy as that. Okay, quickly do number 3. Let's see. Do number 3. Let's see. We want to calculate the association of nitrogen in this particular compound. How do we do it? It is not something that is hard, so we are going to break it down first. We'll break it down first. So this is how we're going to break it down. We take the compound, which is PbNO3, we interpret it to be, write your Pb. Now see this one in bracket, let the 2 go inside. The 2 should go in. So 2 will multiply N and stand to be like this. 2 will multiply this one and stand like this. So interpret it like this. After that, you are now going to tell us what, okay, let me rewrite it like this. So I want to interpret it in the way I will get the oxidation of nitrogen. So oxidation state of Pb is +1. That is Pb. I said +1, +2. Lead is always +2, not 1, please. It's 2. Nitrogen is, that's +2N. Nitrogen is what I'm looking for. So these 2 will come to the front. So this is what I've done. So 2N. Then I will do plus again. Oxygen is always -2. Then multiply by any number under. That is times 6. Everything will give us 0 because it is a compound that doesn't have charge. It's not a radical. So that is how we interpret it. So I have 2 plus 2n plus, okay, if you multiply this, you get minus 12. Everything is equal to 0. So collect like terms. So I can say 2 minus 12 plus 2n is equal to 0. What is this? This is what? Minus 10, I mean. Plus 2n is equal to 0. So take 10 minus 10 to the other side. What do you have? 2n is equal to 10, I mean. Divide both sides by 2. What do you have?
That's 5. That's 5.
N is what?
N is equal to 5.
So my nitrogen is 5. So a positive 5. So now what are you going to do? You are going to say that this 5 is what? V like this. That is if you are calling it in word. If you are calling the IUPAC formula, IUPAC name. This is the IUPAC formula. The name, you are going to use 5 in Roman numeral. So the plus 5 that we have here now is option what? Option D. Do you get it?
Yes, sir.
Option D is the right answer. Option D is the right answer. So I will give you another example so that you can see this second question. Oxidation number of x in XO43 minus. How do we solve this? XO, please write it the way you are seeing it. Not that you should write it anyhow. Anyhow is not acceptable in chemistry. So now, since we have it in radical form, so I will interpret it to be x. I'm looking for x, so x will be there as unknown. Then plus, oxygen is always minus 2, I've told you. Then multiply by anything under, that is 4. Everything will now be equal to the charge that is on top. That's what? Minus 3. Since it's a radical. So, assuming there is no charge on top, everything will be equal to 0. Do you get it now? Assuming there is no charge on top, everything will be equal to 0. Now, I'm going to go from there. I have x plus, when you multiply this, you get minus 8. So, everything is minus 3. So, x minus and plus will give us what? Minus. So, 8 goes to the other side to produce what? Positive sign. You understand? So this means I'm owing 3 naira, I'm having 8 naira. So if I pay my debt, I will still be having what? 5 with me. You understand? So that is x. So x still stands to be producing plus 5. You see that? Now see the last one. The last one is you are asked to determine the oxidation number of sulfur. So this one, see the way I'm going to interpret it as well. So I will interpret it this way: 2H, then plus S, then plus 4O. So I can even put it as 4O like this, no need of brackets. Now, which one am I looking for? I'm looking for sulfur. So that's the only thing that will be left there. Hydrogen is always 1. That's 2 multiplied by 1 plus S plus 4 multiplied by minus 2. Oxygen is always minus 2. Take note of that. So everything will be what? 0. So this one is 2 plus S, then minus 8 is equal to 0. So collect like times 2 minus 8 plus S is equal to 0. This one will give us what? Minus 6 plus S is equal to 0. S will now give us what? 6 go to the other side and take the what? A positive 6. So we have 6. So that is why you always hear them pronounce suffix 6. So that is, in this particular compound, sulfur is having oxidation of 6. So you're hearing sulfate 6, sulfate 6. So if I want to tell you the name, this is an acid. Anytime you want to pronounce an acid, don't start from the first symbol. Don't start calling the name from the first symbol. Let me just give you the summary. The acid starts from H. The H is not pronounced. The H even means the acid. Do you understand? H is the acid. So you start from the back. 4 is tetra. Tetra. O, since it is 3, 1, 2, 3, there are 3 elements coming together. O should be pronounced as oxo. Oxo. Since we have 1 in the middle, which should end with 8. So sulfur should be called what? Sulfate. And we just calculated the oxidation state of sulfur. So you must follow it with the oxidation number, which is what? 6. You write it with an open bracket in Roman numeral form. So now the hydrogen means the acid. So can you see hydrogen is not pronounced at all? Tetraoxosulfate 6 acid, H2SO4. So that is how it is pronounced. Now if you check this, the first one, we can quickly calculate the oxidation state. The oxidation number of the following is this. So sodium is +1, chlorine, we are going to do that. Oxygen is -2, then is equal to 0. From there, what do we do? From there, we can say 1 plus Cl minus 6. And you're going to get Cl to be equal to 5. Mathematics, primary school mathematics. You get chlorine to be 5. So if I want to call this NaClO3 will be, sodium will be called first. Sodium will be called first. After sodium, you are going to the oxygen. So this one will be called first, sodium. Then I'll go back to oxygen. 3 means tri. So tri. Then oxygen will be oxo. Then chlorine will be chlorate. Chlorate. Then this 5, instead of chlorine there, will be in Roman numeral form. This is the answer. That is iupaclane. Iupaclane. And for the second one, so it's copper 2, tetra, oxo, sulfate, 6. Yes, tetraoxosulfate 6, No, now I told you that you are going to. That's pentahydrate. Pentahydrate. Copper 2 tetrasulfate 6 pentahydrate. That is how to call that one. Copper 2 tetrasulfate 6 pentahydrate. So we are going to do the naming of the binary compound. So these two, this one has a +2, that is Mg +2, that is 2 plus, and this one has 2 minus, Abi. So the same thing, Abi. Anytime the thing is having the same number, you just ignore the number and write it as what? MgO. We are after the name, not the formula. So MgO is what? anytime they have two, a metal and oxygen like that, the last one, which is oxygen, we end with ide. You end with ide. So you call the first one, which is magnesium, and the second one will be what? Oxide. So that's how to call it. Anytime you see oxygen and a metal, call the metal and oxygen becomes oxide. You understand? Oxygen becomes oxide. So now let's check this one. This number 2. What is the charge on sodium? Plus 1, Abi. Good. Na plus. Oxygen is always what? 2 minus. We have 1 and 2. So let it cross. So we give us what? Na2 and just what? O. So this one is Na2O. And the name should be what?
Sodium oxide.
No. It should be just sodium oxide. Anytime it is a metal, no matter the number that is attached to it, you don't call it. You understand?
Yes, sir.
If it is a metal, you don't call the number. So it is sodium oxide. But there are some cases that you might call the number if that metal has an oxidation state that is more than 1. Take for example copper. So you might say copper 1 or copper 2. But that is not with respect to the number that is under it. Do you understand?
Yes, sir.
So you can call it iron 1 or iron 2. We are going there anyway. See this one? This one will be what?
Plus 2 and 2 plus.
This one they have the same charge, Abi.
Yes.
But this one positive plus 2, this one negative 2. So and we have it as CaO. And you see, you write it very well, please. CaO is just what? Calcium oxide. CaO is calcium oxide. This one, everyone do this one. Do the number 4. Let me see what you will get in number 4. So that is aluminium oxide on the board, Al2O3. Empirical formula and molecular formula. So we must know what empirical formula is before we start solving problems that involve empirical formula. And the second one, which is molecular formula. Empirical formulae and molecular formulae. Definition. Empirical formulae, it is the simplest possible formula given the ratio of an atom of all the atoms that is present in that compound. So ratio of an atom is the molecule of the compound. That is what we call empirical formulae. So let's go to molecular formulae and explain what we mean by that. Molecular formulae, it is the formulae which expresses the actual numbers of mole of an atom in a compound. They are true formula of molecules. So many molecules, the molecular formula and the empirical formula are one and the same. Like, or for example, we have ammonia. The same thing is the empirical formula and the same thing is the molecular formula. So there's no difference between the empirical formula and the molecular formula. Another one is water. Another one is carbon dioxide, which is carbon 4 oxide. And another one is methane. Methane have the same formula as empirical and molecular formula. So we have a sample. It's an example to show us here how to calculate empirical formula and molecular formula. So we will live here on the board and let us see how we are going to calculate it. So how do you do it? Solution. You are going to draw a table and you analyze the question. The first thing to do is to check the composition. Use your calculator to get the addition. If it is up to 100, then you are good to go. If you add all the percentage, composition, and it is 100, you are good to go. So, but if it is not 100, maybe there is something that you need to do. Maybe you need to read the question very well to see maybe they use the word and the rest. And the rest is something that they didn't make mention of. So now, how many elements do we have? We have hydrogen, we have carbon, and we have chlorine. So I must have 1, 2, okay, let me make it like this. I will have 1, 2, and the third one. So I will have 3. Since I have 3 elements. Now, what will I do next? This first place is for notes. So the first notes I will write is percentage composition. Composition by mass. What is the percent composition? So what are the elements? Hydrogen, carbon. So anytime you see them like that, you start with carbon. So followed by hydrogen and followed by chlorine. So always start, sometimes it might be mixed up. When you see carbon there, start with carbon, followed by hydrogen. Then when oxygen is there, oxygen will be written last. Anytime you see all those group 7 elements, they should come last if they are present there. Now we have, what is the percentage composition? So for carbon is 37.21. You don't need to put percent because percent is already there in the notes. So for hydrogen, it is 7.75. For chlorine, it is 55.04. The next thing is the mole ratio. How do you do the mole ratio? It's as simple as this. Take, what is carbon here? Carbon is 12. Take this one divided by what is given to you as relative atomic mass. That is 37.21 divided by 12. Use your calculator to get that answer. 7.75 divided by 1. Hydrogen is 1. So divided by 1. So that will still give us 7.75. So this one is 55.04 divided by, what is chlorine here? 35.5. So you tell us what you get. Pause the video and quickly do the calculation. Do the calculation to get me. The next stage is to divide through by the smallest. Divide through by the smallest. So which of them is the smallest? So I have 1.55. So I'm dividing this one by 1.55. I'm dividing this one by 1.55. I'm dividing this one by 1.55. So this one I'll get 1.00. So you can pause the video and do your calculation as well. Okay, solve this question and drop your answer in the comment section. Thank you.